thousands of years, structures have been built and dismantled by hand. Transporting materials and tools to build such structures has burdened many projects limited on time and resources. What if there was a portable device that could reshape our ability to conduct large autonomous operations? 3D printing technology has grown rapidly in recent years, and the once stationary concept has started to become increasingly mobile. One company based out of Austin, Texas, has begun the construction of 3D printed houses, utilizing a 28-foot wide by 9-foot tall 3D printer frame. This frame's width is adjustable to accommodate different housing slab sizes, but the overall construction is still limited axially and dimensionally by the nature of the printer design. This type of construction is also performed under predetermined coding conditions, not allowing for real-time modifications in design. In the agricultural industry, chain trenchers are used to dig wide channels for infrastructure, water lines, drainage, and other applications. Current trench digging technology comes in the form of large-scale tractor attachments that are both hard to handle and require human operation. What if these giant 3D additive and subtractive methods could be fully automated with smaller equipment and increased degrees of freedom?
3D Mobile is a portable device that adapts to almost any construction operation anywhere in the world. This device uses a 2D LiDAR sensor paired with a small target tracking camera to communicate to an autonomous robot its exact location relative to the LiDAR system. The LiDAR and camera platform is attached to a centralized pulley system that adjusts the height of the platform to accommodate for the change in altitude of the robot. The constant communication between the autonomous vehicle and sensing platform results in a precise and adaptable real-time construction solution. Applications of this device range all the way from 3D additive methods, such as 3D printing, to 3D subtractive methods like agricultural trench digging.
The LiDAR and target tracking camera platform allows for panning, tilting, and vertical travel on the centralized mast. This elevator platform is operated by a microcontroller and stepper motor. Attached to the left side of the mast is the power supply that powers all these components. The LiDAR and target tracking camera work in tandem to track the location of a mobile device, continuously monitoring its current location and providing real-time 3D reference vectors to guide the device in accordance with a specified task via wireless communication. In this clip, this mobile robot is being monitored and instructed by the 3D mobile setup to essentially trace a geometric pattern that follows the layout of the bricks on this pathway. While this may seem underwhelming or far from any 3D additive and subtractive implications, this is evidence that our innovative LiDAR application is successful in providing real-time 3D location data and can guide a mobile platform to perform a certain task. This design can be augmented by a higher-tech LiDAR system, taller mast, and more sophisticated mobile platform, such as a mobile 3D printer or agricultural trench digger, to autonomously perform large-scale operations without axial restrictions.
3D Mobile is an innovative implementation of LiDAR technology that has broad applications across many industries. We believe our design has the potential to facilitate the universalization of autonomous 3D additive and subtractive methods in construction, agriculture, and other sectors. The functionality and prospects of our design have been proven. Now it's up to the industry experts and field leaders to change the game in autonomous operations.